going to just record some of these because we'll call it a quiz review. So if you added 20 to both sides, then you could add 5x to both sides. People that do this sometimes do this because they want to avoid the negatives, and that's fine. So this gives them 30 equals 5x. Divide by 5, and you get x equals 6. And then do a mental check. 10 take away 5 times 6, which is 30. That would be negative 20, so it checks. That's one method. Okay? So I'm going to do the same problem a different way. So let's shrink that up and try it again. So if you had 10 take away 5x equals negative 20, and you did subtract 10 from both sides, that's what you would have to do, because since there's no add or subtract in front of the 10, you have to think of it as a positive. So in order to get rid of the positive 10, you have to add negative 10 or subtract 10. You have to do that to both sides. And then these cancel, so negative 5x equals negative 30. So divide by negative 5. These cancel to give you a 1x. And a negative divided by a negative is positive, so we still get 6. Okay, so Allie, now you have the problem up there. Are you asking about the 10? Because there's nothing in front of it?
Well, it's just like when y on something, like on somewhere there's a minus sign and x, but on somewhere there's a minus sign and don't. Like on that one there's a minus sign, but on the right side it means like combine it.
So it's just because that's the number. But if you have a negative on this side, to undo the negative, you would add. Over here, you don't have a negative, so you can assume it's a positive, so you do the opposite by subtracting. So you have to develop that skill of figuring out what the opposite is. I'll let you think about that, Katie. Quiz, on the quiz. You would have to come up with one of those two methods, I think, in this case, but either or, not both. In other words, mental math is not an option tomorrow. You have to show your steps, and they have to be traditional algebra steps, because that's what we're testing. AJ. There might be a check, but there won't be several checks. Because it's not practical to check every single problem by hand, long way. So you saw me do a mental check. I may ask you to check your answer, but I probably won't ask you to do it more than once, unless there's just a few questions. But that means, so to do that, let's make sure you know how to do that. 10 minus 5x is the problem, equal to negative 20, right? So we found that our x is 6, so you're going to check it by doing 10 minus 5 times 6, and you want to make sure, or see, if that's equal to negative 20. So 10 minus 30 is negative 20, and so that checks. I might ask you to do that process once on a quiz. Ideally, you would do it with any leftover time. You would check it as much as you could. And then always try to do a quick mental check, but you don't always have time to write everything out. Especially, your age, a lot of you, it's just time consuming to do all the writing. But you could still do a mental check. But I may ask you to show one written check. And then I would actually specifically say it. Nick. 2D. Okay, we're going to go to next question. 2B. So that's 3.5x. So this is a good one because it's variables on both sides, which is a little bit different than the last one. So you could bring the 3.5x over by subtraction. It's actually 3.5x. And just make sure then you have a 0 here. So 130 plus 6.5x is what is on the right-hand side. Then you have to subtract something. So how about we subtract the 130? That gives me negative 130 and 6.5x. So far, so good, Nick? So when you divide by 6.5, oops, divide by 6.5 here, you have an x. And then, you know, 130 over 6.5, or negative 6.5, that's the same as 1300 over 65. So you could do long division, or you could see however, like what I see is 65 goes into 130 twice. Do you see that? So 65, in other words, you have to do long division if you want. I almost never do long division. I just do that kind of thinking. But some way, either this way or 6.5 into 130. And I know I need the negative there in the end. But usually when you learn this in elementary school, you would have done this, right? And you get, either way, you're going to get a negative value, and it's negative 20.
Is there any way that you could do it without the zero? Because for me, that kind of just messes me up a bit more.
Yeah, like I would do the same thing. I would do short division, which is really what I do. So short division to me is 6.5 goes into 13 twice, right? There's no remainder. So 6.5 into 0 is 0. So that doesn't work for everybody. That works for you, though. Do that. Yeah. Jason.
Will there be questions like two variables on the side? Well, the
Variables on both sides. Kind of like the worksheet, you mean?
Yeah.
Not yet. So the green worksheet, that was the other thing I wanted to bring up, is a super challenge, right? We're not quite to where we would have something the level of the green worksheet. Maybe, I take that back, maybe like one problem like 2x plus 6 plus 3x equals 20. Something at that level. You could subtract the 6 out, and you'd say 2x plus 3x equals 14. These are both the like terms. So if there were variables on both sides, it would be about that level of difficulty. Pretty simple, not as complicated as the green worksheet. What time are we out of here? Okay, we're gonna have to stop, but we'll do more questions before the quiz. If it's gonna make it quick, Sammy, I'm not gonna work another problem now. So if it's another problem, I'll be here tomorrow morning, because this is your homework, right? About 10 to 8.
So this relates to any problem to variables on both sides. So like when you subtracting them like from x, you have to subtract on the other side of the x.
Yes, if you do a subtract, like
Like if you subtract 2x.
you would first get all, if they were on one side, you would first group them up. So if you have, as far as if there were variables on both sides, is that what you're talking about? And so, I think this is about as difficult as we're looking at. Okay, thank you.
Okay, so like if you're subtracting 3.5x, could you subtract that from 130, or do you have to?
No, it has to be the x's from the x's.
Okay,
Okay.
if you're subtracting not x.
Then the numbers from the numbers. The variable, this is a variable term. Whoa. Variables from variables, x's from x's. Okay, I'm gonna move on. Remember, this is your homework assignment. You can come and ask questions tomorrow or come in tomorrow morning. But you really do want me to move on because I'm gonna give you a sample quiz problem. So put your hands down. Okay, this is a sample quiz problem. This is actually a problem from your last pink quiz. Do you remember the Chuck E. Cheese problem?
Yeah.
Okay, so it's, the difference is, I'm just gonna remind you, review things I'm gonna ask you tomorrow that weren't really clear on the last quiz. You should, well, first of all, this is the Chuck E. Cheese one, the line. And this was the gateway line. Some things I'm going to ask you. The Y-intercept. The Y-intercept of the Chuck E. Cheese, which I'm going to do in blue. Remember, I wrote on a lot of quizzes, don't forget to put a coordinate. So the Y-intercept for the Chuck E. Cheese line, what is that, AJ? So y equals 50 is one way to write it. And the coordinate would be, Nick?
0.50.
0.50. So you should be able to understand when I say y-intercept. Okay? You should also be able to do slope, which is the rate of change. Hold on. So far I'm just kind of reviewing. To do slope, some of you are struggling a little bit. We went up 50 there. And over, if you look down here, over 10. So slope is the vertical, the change in y. Slope is 50 over 10, which is 5. A number, okay? If I asked you about rate of change, we usually include units. So it's still 5. But it would be $5 per person, because this was about how much it costs a person. So this was number of people that got erased. And this was the cost in dollars. And so the Y was the cost, the X was the people. Okay? So that's all old, Jason.
So the Y-intercept for gateway card would be 0.
Good point. So the Y-intercept for gateway, the Y-intercept would be 0, 0. So it's where it starts. And the slope for gateway would be up 100. Do you see it went 100 to 10? From one point on this, this is the point 10, 100. You see where I'm getting that?
Why did you pick 10 for that?
10. Because this coordinate right here is up at 100 over 10 up 100.
No, but I know that's how you got that, but why did 10
Oh, because it was a point that I could read on the graph.
Oh.
You just have to pick a point, and so since I have no grid marks, it's the only point I can use.
Oh.
You might have other choices if you had grid marks. So the slope here would be 100 over 10, which is 10, right? Okay. So the only new thing is to figure out where these are equal. Now you guys know how to do it with a graph, right? So my question to you is, if you didn't have the graph, if you remember that the Chuck E. Cheese equation was the slope of 5x plus the starting point of 50, and the gateway equation was the slope of 10x and no starting point, just a starting point of 0. Okay. So when is this y value equal to this y value? How could you do that without a graph? What would you do? Patrick.
You do 10 divided by 50, and then you still have 5x left, so it's
You have the right idea. She's using both equations, but it's not exactly perfect. What have we been doing the last couple days? Figuring out x with 1 and 2 step equations, right? So I really want to know when this part, this y value, is equal to this y value. What do you do, Suki? Watch, that's exactly right. You set them equal. When is this y value equal to this y value?
So once you get rid of the 50 and the 5.
Yeah, you'd subtract 5x from both sides. And you get 5x equals 50.
So I divide
Divide by 5. And you get x equals 10, right? And x represents people, right? So 10 people. And then if you plug people into here, 10 times 10 is 100, and y represents money, right? So 10 people cost $100, right? So the coordinate 10, 100, that's where you break even. What's it mean to break even? AJ?
Your expense, like you've made enough money to cancel out your expenses.
Right. So no matter what in this problem, no matter which company you went with, you spend the same amount of money for 10 people. No matter what, it's the same. But once you do more than 10 people or less than 10 people, one place is a better deal than the other. If the deal's the same, we just say it's a break-even point. Like maybe your income and your costs in a business deal, they're the same. That's when you start making money. So a break-even point is where the lines cross. Or if I just say, when are the two equations the same? You just set the two equations equal. Does that make sense? So what I told the other class is on page 67, if you want to study one of these for the test, how to set one up, try finding that break-even point, and it's not the whole problem. So try, it's actually page 68. The type of question you would be asked is D. Something like D. And that would be a good thing to study tonight, and then you could come in and ask a question about it. But really, I'll record this. This is even easier because it's a simpler, the numbers work out really nice. You should be able to do a simple break even. It's one question. Everything else, is vocab. Make sure you know what the intercept is now, what the slope is, and how to solve 1 and 2 step equations. Does that make sense? Okay, I'm going to stop